In 2015, the number of global devices connected to the internet hit 15 billion. By 2020, this count is projected to exceed 33 billion devices. These devices include your phones, tablets, computers, wearables, and the fastest growing segment, the Internet of Things. In the not too distant future, homes with over 50 wireless devices will be common. These include the obvious, such as computers and mobile phones, and as wireless continues its expansion to every application, remote controls, thermostats, smoke alarms, security systems, light bulbs, ceiling fans, appliances, and many more which will be added to the list. To address the explosive growth in devices, two significant developments are taking place in the wireless industry. First, more sharing of unlicensed spectrum, called coexistence, and second, access points with the ability to serve multiple devices simultaneously, further increasing Airlink efficiency. This new feature is called multi-user MIMO, or MU-MIMO for short. While Wi-Fi dominates use of the ISM and Uni unlicensed bands today, emerging and new wireless access technologies are increasingly being employed into these bands. Unfortunately, the available radio spectrum isn't growing anywhere near as fast as the demand generated by the growth in devices. For example, in the 2.4 GHz ISM band, we already have spectrum sharing by Wi-Fi with Bluetooth and Zigbee and newcomers like Thread. But the 5 GHz Uni band is more complicated. Highlighting the spectrum shortage, we look at the 5 GHz Uni band. In blue, there is 515 MHz of spectrum already allocated for unlicensed use. The gray bands show an additional 240 MHz targeted for availability by the FCC. The 5 GHz band is heavily used by Wi-Fi for the most advanced 802.11 features. Now it is also targeted for use by cellular offload technologies such as LTE unlicensed and lte-laa. These technologies must coexist by fairly sharing the available spectrum. The sharing of the available radio spectrum used by these devices, with needs ranging from the occasional transfer of a few bytes to real-time streaming of high-definition video, is called coexistence. While Wi-Fi networks are proven to coexist with themselves, the coexistence of new technologies such as LTE unlicensed and lte-laa is unproven. These new technologies use different physical layer access mechanisms with proprietary adaptation mechanisms and unproven cross-technology coexistence that is accepted by the entire technology community. This problem is complicated by the industry having a large number of chipset implementations and device vendors all racing to deliver the next generation of fast wireless access. If untested, millions of new products will be delivered that potentially interfere with the over 1 billion deployed Wi-Fi devices. Unfortunately, the complexity of testing in free space and inability to set up valid, meaningful, and repeatable comparative tests demand solutions that, to this point, have been impossible. octoScope's wireless testbed suite of products is designed to address exactly this challenge. Through the complete isolation and repeatability of the octoBox family of products, precise control over the wireless environment enables the careful evaluation of coexistence behavior in an isolated, instrumented, and repeatable environment. The octoScope coexistence testbed shown here allows different networks to be brought into proximity to each other in varying ways to explore the behaviors of coexistence and/or competition between networks. Networks overlapping and hidden node scenarios can all be emulated. Coexistence elements such as channel selection, contention, load balancing, and rate adaptation are easy to evaluate, aiding the engineering and evaluation process around coexistence. The peculiarities of coexistence, which are many, can now be evaluated in a repeatable, completely isolated environment. An additional mechanism for exploring coexistence behavior is iGen. iGen generates Wi-Fi traffic and common interference waveforms present in the 2.4 and 5 GHz bands. iGen can be used for inserting Wi-Fi traffic or for generating interference commonly found in the ISM and Uni bands. Here we see iGen's user interface for Wi-Fi traffic generation. The Wi-Fi mode, the channel bandwidth, the guard interval, all the settings of the Wi-Fi traffic can be selected. A PCAP file can be used as a data source for traffic playback. When the test is started, Wi-Fi traffic will be inserted onto the program channel in a standards-compliant manner. This means that the Wi-Fi traffic generation uses the appropriate listen-before-talk and back-off mechanism present in Wi-Fi. This effectively loads the Wi-Fi channel in a compliant manner. iGen can also disable the compliant mode of traffic insertion by disabling all contention mechanisms. In this mode, iGen will insert traffic onto the selected Wi-Fi channels in a non-compliant manner, causing collisions. This can be used to simulate hidden nodes and misbehaving clients. Also present in iGen is waveform interference mode. iGen can generate waveform interference of various types that would be encountered in the Wi-Fi environment. Bluetooth or baby monitors, microwave ovens, and Zigbee can all be generated. Radar pulses from airport weather radars present in the 5 GHz unibands can also be generated. This is useful for testing dynamic frequency selection capability of Wi-Fi access points that operate in the bands shared with radar. Finally, iGen can also take in a CSV file to define how interference is generated. This is useful for customizing the interference environment. With AirLink efficiency critical to product success, the careful evaluation of new advanced product capabilities is essential. Achieving the higher data rates of 802.11ac and the under development 802.11ax depend upon ever more efficient techniques to optimize AirLink capacity. Multi-user MIMO, or MU-MIMO, is a big step forward in achieving this goal via simultaneous transmissions to multiple clients in the same space, a paradigm shift for Wi-Fi that dramatically increases the access point's aggregate throughput. It is important to note that MU-MIMO benefits every client connected to an access point, even non-MU-MIMO clients, as MU-MIMO enables greater airtime efficiency, leading to increased overall access point capacity and throughput. octoScope's tools enable precise exploration into the behavior of MU-MIMO. octoScope's multi-user MIMO testbed consists of 2 chambers, one for the access point under test, and the second for the MU-MIMO client pool. In the top chamber, we have an access point surrounded by antennas to provide for different angles of arrival. These different antennas enable the very high spatial diversity that is key to MU-MIMO gains. In the bottom chamber is a pool of MU-MIMO clients. In this case, we are showing 3 laptops, each containing a multi-user MIMO Wi-Fi connection. These devices are connected through RF cabling to the antennas in the chamber above. As MU-MIMO is a downlink technology, we are using a traffic generator, octoScope's multiperf in this case, to generate traffic to the 3 MU-MIMO client laptops. We are metering the aggregate traffic to the clients as shown. Here we see the results of MU-MIMO. Under non-MU mode, about 311 megabits per second aggregate data rate is achieved. With MU enabled, the aggregate access point traffic to the clients using MU-MIMO mode is near theoretical 2.3 times what is achieved when MU-MIMO is switched off. This simple setup clearly shows the gains that are possible with MU-MIMO. This repeatable test is only possible in an environment that is completely isolated and one which provides spatial diversity to the clients to allow beamforming to occur, the octoBox. More complex scenarios in the octoScope MU-MIMO testbed allow for the exploration of behavior with many devices and a mixture of over-the-air spatial correlation properties, stressing the ability of the access point to optimally schedule transmissions. All of this is highly repeatable and fully automated. As the unlicensed bands become more crowded with Wi-Fi, Bluetooth, cellular offload, and many other wireless technologies serving every application, including the Internet of Things, coexistence behavior and faster access technologies will define product success. Given the complexities inherent in understanding all aspects of product behavior and performance, only octoScope provides powerful, robust, and easy-to-use solutions that help to understand and optimize the next generation of wireless products.